everyone, and welcome to this short video on arcs and sectors, how to find the radius or diameter. So we'll quickly look at the two formulae you should already know. So a very common exam question in National 5 Maths is to do with arcs and sectors. So you've got your top formula, sector area, bottom formula for arc length. Sometimes you might be asked to work backwards and find theta, the angle at the centre. And then often, what we're going to look at today, you'll be asked to find the radius or the diameter in a question. Okay, so slightly different, but we're going to be working backwards to find that. So we're going to look at two different methods. The first, I'm going to mention just briefly, it depends really how confident you are with changing the subject of the formula. So if you look at this immediately and think this looks way too complicated, do not panic, because I'm going to go over a different version in a second. Okay, so if you were asked to find the length of the radius in a question where you're given the sector area, you would have to rearrange this formula to get r on its own, and you'd end up with this sort of complicated looking formula on the right hand side. Do not have to use this method, but if you do, you would rearrange it to get r on its own, and then you would substitute in the numbers that you're told in the question. So you would substitute a number in for your sector area and a number in for your angle theta, and then you would stick this all in your calculator to get the radius. So you would achieve full marks if you use this version for the question that you're asked. Another version though, we're going to do, it does still involve rearranging. You have to rearrange in a backwards sort of question, but it's not going to look as complicated as this. So we'll look at two examples that use this. Okay, so the first example, we've got a sector on the right hand side. The sector shown has arc length 15 centimetres. Okay, so I'm going to highlight some important information here. The arc length is 15 centimetres and the angle at the centre is 123 degrees. And we want to find missing length x. Okay, so start off, if we are given the arc length, we need to select the correct formula. So remember, arc length, our formula is, so it's theta over 360 times pi d. So remember, it's a fraction of the circumference. Circumference is pi d, fraction comes from the angle over 360. What we're then going to do is substitute in things we are told in the question. So in the question we've got arc length was 15 centimetres, so let's put 15 where the arc length was. The angle theta is 123 times pi times d. So what we're going to work out here is what d is. Okay, the next bit, we're not going to rearrange it just yet, we're going to simplify this slightly. So what I'm going to do is I'm going to put all of that in my calculator. So I'm going to put 123 over 360 times pi into my calculator. 15 is going to stay where it is. And what you get out is a really pretty long decimal. So you get out 1.07337 and it keeps going. So I'm not going to round this just yet. So I've got long decimal times by d. What we want though is we want to find out what d is. Okay, so I've got a number multiplied by d. What I'm going to do to get rid of that number is divide both sides of the equal sign by that number. So I'm going to divide both sides by the long decimal. Okay, we're not rounding it at all. We're just keeping it as it is, and you're not going to clear your calculator. So do not press on or the clear button, because what you're going to do in your calculator, so this is what you're going to put in your calculator. You're going to put 15 divided by, and then you're going to press the answer button. So what that'll do, sorry guys. So what that'll do is it'll keep all of the decimal in your calculator. It won't round it, so you won't lose any marks due to rounding errors. It'll keep the whole long decimal in your calculator. So when we divide by the long decimal, you get d on its own. And if you do 15 divided by the answer, you end up with 13.97458, another longish decimal, which we can now round. So we'll now round that to 14 centimetres. Okay, if you look back at the question though, so just at the top of the page, if we look back at the question, we've just worked out the diameter is 14. X isn't the diameter. So if you imagine that it was a full circle, if you imagine this as a full circle, x is actually the radius. So what we need to do is to calculate the radius in this question. So the very, very last step, to find length x, you're going to take the diameter and you're going to divide it by 2. So final answer, x is 7 centimetres. Okay, so that's it for example 1. So you're plugging in your numbers in the correct formula, simplifying it slightly, and then you're going to divide both sides by the number you've multiplied d by. So that's the first example. We'll look at another one just quickly. Slightly different, it's to do with the area of a minor sector. Okay, so we've got the area of minor sector AOB is 95.5 millimetres squared. You've also got the angle at the centre over here is 76 degrees. Okay, we've got the area of the minor sector. Remember the word minor, it's the small sector. So there are 2 sectors in this circle. The minor sector is this one here. This one here would be the major sector, but we don't need the major sector just now. Okay, we need the minor sector. So if we've got the area of a sector, starting off with the correct formula, so sector area, remember, is a fraction, there's your fraction, of the area of the full circle. So it's a fraction times pi r squared. Very similar to last time, we're just going to do the next couple of steps. We're going to substitute in the numbers that we know, and then we are going to simplify. Oops, sorry. Oh, it's fine. So 76 over 360 times pi times r squared. Simplifying slightly, so all of that bit goes in your calculator. And you get another long decimal out, believe it or not. You get, it's 0.66325. Also keeps going on, but we're not going to round it just yet. Also, again, same as last time, we've got something, a number, times by r squared. To remove the number, we're going to divide both sides of the equal sign by that number. So you don't actually have to write all of this decimal down, but you do need to keep it in your calculator. Okay, so don't write, you might not need to write the entire number down, but keep it in your calculator. So when we divide both sides by that number, we're left with r squared. And remember, if we're dividing by a number that is smaller than 1, if you divide by something smaller than 1, your number's actually going to get bigger. So what we end up with is 143.99334. That's r squared. If we want just r on its own, we're going to square root both sides. So the radius for this question is 11.999, oops, sorry, 11.99972 blah 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 blah, which we're going to round to 12, not centimetres, it's 12 millimetres this question. Don't know why it doesn't like that, sorry, 2 seconds. Okay, so 12 millimetres. Not the end of the question though. So once again, if we look back at the question, just double check that you've definitely answered the question. So it says to find the radius of the circle, which we've done, tick, and hence its circumference. So that's the last thing we need to do, is to find the circumference of this circle. So remember, circumference is the distance around the outside. So the last thing we are going to do is find the circumference of the circle. Remember, circumference, formula is very simple, it's just pi times by the diameter. So circumference is pi d. We've got the radius, remember the diameter is going to be double that. So pi times 24, which is 75.398. And then we can round for a very, very final answer. 75.4 millimetres. I don't know why it hates m's, but this will give you a good laugh. There you go. 75 millimetres. Remember, circumference is just a distance, so we're using millimetres. We only use square units if you're dealing with area. So that's it for sort of rearranging your formula to get the radius or diameter on its own. I hope this has helped you out a little bit. Good luck with the rest of the Arts and Textures topic. Thanks for listening.